that the first thing they look at in 9.1, it's union and intersection. Of finite sets. Okay, and the very first thing you've got to know is when they talk about the union intersection. When you talk about the union, that's where you're going to take two things and combine it together. So you can basically say it this way. It's any element, any number, any variable, any whatever they give you two lists of things. It's any element that's in either set. And we talk about the intersection. That's any element that's in both sets. Okay, so union, you want anything that's in either set. For intersection, you got to have what's in both sets when you're looking at the different parts of this thing. And the way they're going to set these up when they first start talking about these is they're going to tell you that you have two sets. Set M, and then they'll just give you a list of numbers. And then set G. Okay, and what they're going to ask you to do is they're saying, all right, here's your two sets of numbers that you have. They're going to ask you to find the union and find the intersection. And when we start working this, and they don't talk about it just yet, but in a couple of problems they're going to do this. The symbol for union, in a little bit when we start doing this where you got two separate sets of numbers, the symbol for union is going to be a U. When we do intersection, it's going to be an upside down. Now, they don't use it right now because of how it's set up. When we start doing some graphs in a little bit, and we start looking at graphs of numbers on a number line, they're going to make you use the U and the intersection thing that's here. Okay, so that's our two numbers. They'll just say, all right, find the intersection. And if it's the intersection, that's everything that you've got in common, so that would start off with -1. Got your 4, and that's it. So for your intersection, be -1 and 4. Okay, for the union, that's everything. Any number that shows up, and that's where you just go through and start checking it off. You've got -1 here and here, so obviously you can get rid of that one. You've got the 0 next, and they don't have to be in order, but since they go ahead and give you all the numbers in order, you can go ahead and put them in order. So there's your 0. Next number you have is 2. Oh, sorry, you got 1. Then we got 2. We've got 4, 5, 6, 7, and then 8. And when a number repeats, like the ones that we had here, you don't have to go back and write those numbers twice because it's already in that set of numbers that you're looking at. Okay, so, and again, they ask you to kind of do this part. Intersection, well, we'll go ahead and put it out to the side here. This is where they would have M, and we'll go like an upside down U. And then for the union, be M union G. Okay, so there's one where they just give you a list of numbers and say, okay, here's a big list of numbers. Just go in there and tell me intersections of the numbers that's in both of them, and union, that's any number in any list. Just lay the whole thing out there. Okay, so what next thing they do is they're still going to have you do union intersection, but this time instead of it just being specific numbers, this time it's on intervals. And this is where they're going to have you go back to your less thans and your greater thans. And they kind of showed you that part of it there with the first part when we talked about that one. But for this part of it, this is where we actually kind of have it here. So they'll tell you something like this, that A is, and they do a little funny notation with it. You've got your Z slash, and then they'll tell you something like this, where Z is less than 4. Okay, now when you get this part of it, where you've got the Z with the slash and everything else, you really don't need this part of it. That's just the notation part. You just need to know that A is Z minus 4, and that B would be Z greater than or equal to 6. So the other two parts are that's just the notation part of it. They don't really mean anything. It's just there just because that's the way, when you talk about some of the notation stuff, that's the way it's set up. Okay. So let's go A union B. And this is one where really, to me, it's almost better to go back and put this in a graph form, because without the graph, sometimes you're just kind of trying to picture it in your head, and sometimes it gets lost. So just make a quick number line. And just do these in two different colors. We'll do this one in red, and we'll do this one in green. Okay, so if we want everything greater than or equal to 6 on this one, solid circle at 6, and everything headed off this way. And we've got Z less than 4, so we'll start at 4. This one's an open circle at 4. Everything headed that way. Okay, so if they ask for the union, that would, if they ask for a graph of one, that would be the graph that you're looking at. Just put the two numbers on there and see what you get. For that particular part of it, there was no overlap. So, and again, anything that shows up would be your answer. So, graph-wise, that would be your answer. Now, they're going to ask you to write the answer not in graph form. They're going to ask you to put it back in interval notation. So, to go to interval notation, you just tell me everything that's on this list. You're going all the way to negative infinity. You're going up to 4. It's an open circle, so we'll put a parentheses there. You're skipping over everything in the middle, so you're just going to basically go over here to 6. Start with a bracket because it's a solid circle. And then chase it off to infinity. And whenever you do the union here, if you skip over a section, just put a U in the middle. So this would be your graph, and this would be your interval notation. Okay, and union's pretty easy. You just take the graph you've got, you lay it out there, and see whatever's colored with it. And whatever you cover, that's your answer. When you do the intersection, you're basically going to take the exact same graph that you have here, and then you tell me, okay, where did the two lines cross over? Well, they didn't, did they? Because this one you started at 4 and went left. This one when we started at 6 went right. They didn't have anything in common. So there's no overlap here on the graphs. If there's no overlap, then that means you have no solution. And I'll tell you for that one, you just put a 0 with a slash through it. Okay, so, and that's the best way of looking at this one. And there's different ways, but the easiest way to do this is when they give you two sets of numbers, just put those two sets of numbers on a graph, and if you can color one in one color, one in the other, it makes it a little bit easier. And then just look at it. Whatever you cover, again, that's your answer for your union. And wherever the overlap is, that's going to be your intersection. So whenever you think about the intersection, just think that's your overlap. Okay, now let me give you one. That one had a little bit of a trick question to it. Let's give you another word. Same kind of thing, but just a little different look to it here. Okay, so we'll go back and graph these, and again, we'll do this part in red, and then we'll do this part in green. Okay, so doing everything greater than 2 in red, that's an open circle at 2, headed in that direction. Doing everything less than or equal to 7 in green, that's going to be a solid circle, headed in that direction. Yep, so they'll ask you for the union and ask you for the intersection. And again, once you've got those two graphs, once you've used the two parts of the inequalities and graphed them here, you're really not worried about that one. You're just looking at the graph now. Okay, so if you go for union, green line covered everything from here to here. Red line covered everything from there to there. So what all did we cover? Everything, right? So, because now you may say, well, what about the open circle here? Well, when you had the open circle, the green line covered that point. So for that part of it, that one was just going to be negative infinity all the way to infinity. There you go. So if you happen to cover everything, well, there you go. You've got everything you're looking for. And this is where I wish we had like yellow and blue to make green, or red and blue to make purple, or something like that. For the intersection, this is where you're looking for both parts. So you've got the red going from here to here, the green going from here to here. Where you've got the red and the green lines, that's your answer for your intersection. So your intersection is everything from 2 to 7. It'd almost be good if you could kind of stagger them just a little bit. So everywhere you've got red and green, that's your answer. So when you get to here, again, you don't have red there. You've got that open circle. So basically, you're skipping everything starting at 2, but not actually using 2. You're going up to 7, and it's got a solid circle there. So you put that on it. Okay, so when they give you the 2 sets, graph those 2 lines, and wherever the 2 colors overlap, that's your answer for your union. Sorry, for your intersection. Anything at all that's covered, that's what you've got for the union. And that's really only 2 trick questions you could come down to it, is that sometimes you're going to get infinitely many solutions where you're covering everything, and on the flip side, you've got this gap in the middle where sometimes you don't have an intersection, so that gives you no solution part of it there. Most of the time, you wind up with something kind of like this, where you're going from one range to the other. But that kind of basically covers everything. Any answer you could possibly get there, it showed up in one of those 2 examples. Either all of the numbers, or none of the numbers, or just a range from here to here, or a range that you skipped over from one piece to the other. Okay. And what they do is they say, all right, well, if that makes sense with how the numbers are set up and what you're doing with it, is they're going to ask you to start solving inequalities so that you get an answer that looks like this, or you get an answer that looks like that, and then you're going to tell me, well, okay, what's this going to be? Is this the union, or is it the intersection? They're going to ask you kind of what to do with it, and you're just going to kind of figure it out from here. Okay. Okay, so this one's not objective that's on there. It's more of getting ready for the next objective that they give to you. So before we do the compound, let's make sure we can do just a regular inequality. Okay, so let's say we're doing 2x plus 3 is less than 7. Okay, and here's the one thing you've got to know. For inequalities and equations, there's only one difference for what you do. That you're going to solve this thing like a regular equation. And that handwriting is terrible, so let's try that again. And there's only one exception to where you do something different with an inequality that you wouldn't do with an equation. Yeah, when you multiply or divide both sides by a negative number, you've got to flip your inequality sign. Okay, now, and the one thing that we probably didn't do back here, and they just kind of throw this part in here and just assume you know this. Let me back up for just a second when we're graphing these. That if you have less than or greater than, when you start graphing these, that's when you're going to use an open circle. And when you have less than or equal to or greater than or equal to, that's when you're going to have a solid circle. Because I think this is part of it. They just kind of skip over and assume that you know all this stuff and you've been doing math for a long time. So this is one thing we've got to kind of back up and remind you of when we're graphing these. Is that's kind of the basics you need when you start graphing these lines and you start putting circles in here. So less than or greater than, it's an open circle. Less than equal to, greater than equal to. If you put the bar underneath it, then that's when you're going to do a solid circle when you go on that part. And when you start graphing these, when you go from the lines to the inequalities, this is when you're going to use parentheses for interval notation. And when you've got your solid circles, that's when you're going to use the square brackets. And they were kind of doing that in the first part, and they just had it there. And I think there was a little bit of talk about interval notation and some other stuff back in Chapter 8, so let's go back and remind you again, because sometimes they do a good job of reminding you of these things, sometimes they don't. They just kind of assume that you know those. So that way we can kind of pick up with it just a little bit here and remind you. Okay, so we're bottom of the page. So let's take this 2x plus 3 less than 7. We'll go over back on another sheet here and start this one and go through it. Okay, so that's what we're going to solve and graph. So we'll do that. Okay, so solving it on this one. Just subtract 3 from both sides. So we've got 2x is less than 4. Divide both sides by 2. You got x less than 2. Okay, so they ask you to solve it. That's the part where you have it, you've solved it, you've got that part of it. Now they're going to usually ask you to turn back around, and once you've got it solved, go back and graph it. And for this one, since you've only got the one number, we only have to put the number at the 2, and then you're going to turn around and start putting a graph on that, and then once we've got the graph, then we'll give you interval notation. So basically we've got all 3 parts of it here. Alright, so you've got x less than 2. So that's an open circle at 2. And if nobody's ever shown you this, then hopefully the light bulb will come on here. Whichever way this arrow goes, that's the exact same arrow you've got to put on the graph over here. So that arrow has to fit on that end, so that means this thing has got to go that way. Now, that works as long as you always put x on the left side. That if you put x over here on the right side of your inequality, then basically your arrows are going opposite. So whenever you solve these, solving, you can move stuff around, do whatever you do. But at the end, if you come back and you get a problem and you've got 2 is greater than x in your answer, before you graph it, switch this, put the x first, put the 2 second, and if you think about it, in this case, the arrow's pointed at the x, or the alligator's eating the 2. If you reverse it, put the x first, it's still got to do the same thing, so it'd have to go that way. So if you flip the front and the back, you've also got to flip the direction because the whole thing is turned 180 degrees. So if you do get a problem and they solve it and you've got the number first, just flip the whole thing back around so you've got it this way, and now your arrow is first, or your x is first, and the arrow will match up and tell you which way you want to go. So when you're going through inequalities, that's really the only 2 things that you've got to worry about, is if you multiply or divide by a negative, and if you happen to get the x on the right hand side, that's when you want to flip this thing around and get it back to there. Okay, last thing here, interval notation. You're going from negative infinity up to 2. And again, the 2's got an open circle, so that means you're going to use parentheses. So that would be your answer in interval notation. Okay, so there's your answer if you're solving it. There's your answer if you're graphing it. There's your answer in interval notation. And they'll ask you for any one or all three answers as you're kind of going through these. Okay, so let's give you one here where you've got to work with a negative. Let's go back up here. So that was example 1. Okay, so let's go with negative 4x minus 3, and let's have that be less than or equal to negative 11. Okay, again, they'll ask you to solve it, and then graph it or put the answer in interval notation, whichever way it is. And again, solving-wise, do it just like you normally would do. If you've got 4x minus 3 equals a negative 11, first thing is you would add the 3 on both sides to get rid of that negative 3. So you got negative 4x less than or equal to negative 8. And on your next step, you're going to divide both sides by negative 4. And as soon as you do that, as soon as you're dividing both sides by that, and again, sometimes you'll have one where you might do some distributive property on one side. It's only when you, basically it's almost like every time we do this, it's that last step. When you get to the last step and you're multiplying or dividing, if that number that's with the x is negative, that's when you got to flip this thing around. So now it's got to go this way, and then your x is here, and negative 8 divided by negative 4, that's a positive 2. Okay, so with this one, we're back at 2. But this time, now we're going to the right side. So for this one, you would need a solid circle. And arrows pointed to the right, so now this thing is going to head off in this direction. And then the last piece for interval notation. Got a solid circle at 2. Head off to infinity, and then, so we'll do a square bracket on the 2 and the parentheses on infinity. And with infinity, it doesn't matter whether it's a less than, equal to, greater than, equal to, or greater than, less than. You never can stop at infinity. You give me a number, I can always add 1 to it. So infinity, you never can put a cap on it. It's always going to keep going and going and going and going. Much like our national debt, it just keeps growing and growing and growing. So there's your two choices of what you're going to do if you just graph an inequality. You got your less thans, you got your greater thans. And again, solid circles go with the bar underneath it. If it doesn't have the bar, it's an open circle. Okay, so there's the basics of what we're looking at. Let me show you one more thing on those before we get back to we're on track here. Just in case they happen to throw you one like this, just so that you might be prepared for it. Okay, so let's say you've got a half x minus 3/4 greater than or equal to 5/8 x. Okay, and the obvious thing on this one is it's got fractions. And we don't like fractions, right? Okay, so here's what we're going to do. If you don't like fractions, then instead of rewriting it where you've got the least common denominator and do all that stuff, that's fine. And this works for almost every single time in any equation that you ever do if you have a fraction. There's one or two times where it doesn't, but 99% of the time, if you've got a fraction equation and you're working with it and you don't like the fractions, find out what the least common denominator is and multiply every single term by that, and then the fractions are gone. Okay, so for this one, 2, 4, and 8. you start counting by 2s and 4s and 8s, what's the first number they all have in common? All have an 8, right? Now, again, because your biggest number is 8, if you start counting by 8s, eventually, 16 would work, 24 would work. But the one number that gets rid of everything with the smallest amount there would be an 8. So we'll take every single number here. We're going to multiply it by 8. We've got 8 times a half x. Scoot this over just a little bit. Minus 3/4 times 8. That is greater than or equal to 8 times 5/8. Okay, and what that should do, if you've still got fractions left over, that means you didn't pick the right number to cancel out the fractions, because it should be that you should knock out all the fractions. 2 will go into 8 4 times. So now you've got 4 times 1, which is just 4, so that's 4x. You've got negative 3/4 times 8, so 4 will go into 8 2 times, left with 3 times 2 for 6. Greater than or equal to, we've got 8 times 5/8x. In that case, that 8 should cancel that 8. So we've got 1 times 5 for 5x. Okay, and given those two equations, between this one and this one, I think most everybody would say, yeah, I like this one a lot better, because that's the exact same thing. We've just gotten rid of the fraction. So now you're going to solve this equation. Okay, now you've got two options on this one. You can either move the 4x over here and then we'll go back and rearrange it, or if you're one of those people and you're like, well, if I got to keep x on the left-hand side to graph this thing, let me get all the x's over here and I'll move the numbers over there. That's fine. Either way you want to go is fine. So for this one, just so we keep the x's on the one side and we don't have to worry about flipping the inequality so much, let's just subtract this 5x and move it over here. So it's on the left-hand side. So we've got negative x minus 6 greater than or equal to 0. So now we've got the x on the left-hand side. Just need to move this 6 over to the right-hand side. So we've got negative x is greater than or equal to 6. Okay, now the only thing with this one is it needs to be a positive x. So basically our next line is we're going to divide this thing by negative 1 to cancel these two parts out. And then once we do that, that means we've got to flip this thing to being a less than problem. 6 divided by negative 1 is a negative 6. Okay. So if you do happen to get a fraction one, I can't guarantee that everybody will or nobody will, don't know. But if you happen to get a fraction problem and you're going through these, just multiply by a number to get rid of all the fractions, and then from there you're just solving a regular equation. If you have to graph that one, this one we're at negative 6. It's headed off to the left. Solid circle. And for interval notation, well, we're going from negative infinity up to negative 6, and that one's going to have a square bracket on the negative 6. Okay, so all that's just kind of background in the middle there, because they ask you to do compound inequalities, and we didn't look at just regular inequalities, so there's our regular inequalities. All right, so here we go. Here's where we're solving compound inequalities. And you have basically two types. Type 1 is an AND statement. Well, actually, we'll use the word and type 2 is an OR statement. Okay, and when you talk about the ANDs and the ORs on these, that an AND statement, that's the same thing as an intersection. When you talk about an OR statement, that's the same thing as a union. So the AND statement, that's the overlap of whatever two parts of the graphs they give to you. If it's an OR statement, it's anything that's on the graph. Doesn't matter what it is, you tell me anything that shows up off the graph of it, and that's the answer that you're looking for. Okay, so let's give you a couple different options on these, show you all the different things you can see here. Because with the AND, there's actually two different ways they'll show you this one. One time where they actually use the word AND, the next time they don't, and we'll show you both of those. With an OR statement, you're going to have the OR in it every single time. That's the only way you can do an OR statement. All right, so let's do this. Let's go 4x minus 5 less than negative 29, or 3x plus 6 is greater than 6. And they're going to ask you to solve it and graph it. And we're going to go ahead and do interval notation even if they don't ask it, because at some point in time they're going to ask it, so we're just going to go ahead and do all three of it here. Okay, so when you solve and graph it, you basically take the first equation you've got, or first inequality, solve that one. Nothing special with it, so for this one, first thing you would do is just add 5 to both sides. We've got 4x less than negative 24. Divide both sides by 4. Now, and here's the thing on this one. Sometimes people ask, well, do we need to put that inequality? For this one, no, because you divided by the number with x was positive, so you divide both sides by positive 4, so you don't. If this number over here by itself is negative, it doesn't have any impact on whether you're going to flip this side. So this one, it's just x less than negative 6. Okay, then we'll put the OR. And then for this one, we'll do the same thing over here. We'll solve this equation. For this one, just minus 6 on both sides. Got 3x greater than 0. And when you divide both sides by 3, it's just x greater than 0. And when they ask you to solve, there's your solve answer. Okay. And again, the good thing about a graph when you're doing the OR statement is that graph is just those two things on a number line, and you just cover up whatever happens to pop in there. So this one is everything less than negative 6, so we're going to go to negative 6. Open circle here, head off to the left. X greater than 0, open circle at 0, head off to the right. And then for interval notation, once you've got your graph, you just pull the numbers off the graph. This one goes to negative infinity. We got to negative 6, and we stopped at negative 6. Jumped it back to 0, so that would be our U for union. Start at 0, and then chase this thing off to infinity. And the ORs are almost always the easiest one to do just because of how it's set up when you go through these problems. The AND statements, sometimes there's a little bit more work in the graph that you have to do just because of how it's set up, because you're looking for the overlap. But the ORs, it's pretty easy. You just put it on a graph, you just cover it, and whatever you get, that's what you get. Okay, for the AND statement. Go 3x plus 4 less than 19 and 4x minus 5 greater than negative 25. And as long as I give you the word AND for this part of it, it's just like the OR statement. Just go ahead and solve the two parts of it. So for this one, you would subtract 4 from both sides. You've got 3x is less than 15. No negatives, so we don't have to worry about flipping any signs here. Divide both sides by 3. Got x less than 5. Again, when we think about the AND, that's got to be the overlap of the two graphs. On the right one, we've got a negative 5, so first thing is we would do add 5 to both sides. That's 4x greater than or equal to negative 20. And again, the number with the x is positive, so we don't have to flip any signs. So when you divide, this one is x is greater than or equal to negative 5. Okay, so they ask you to solve it. There's your answer for when you solve it. It's got to be x is less than 5 and x is greater than or equal to negative 5. Okay, now when you graph it, a little bit different, because if it's an AND, it's got to be the overlap of the two answers. So this is where you got to have the yellow and blue make green, or the red and purple, or red and blue make purple. You've got to find out where they cross over each other. So if we start with the negative 5 here, or x is less than 5. There's a 5, there's our negative 5. Everything less than 5, that's an open circle going this way. And for everything greater than negative 5, that's a solid circle here, headed that way. Okay, and with the AND part of it, that means you have to look for where you have both, if you do two different colors, where the two colors overlap each other. Well, that's everything from negative 5 up to positive 5. So the actual answer on this one, this is almost how you work it out here. So that if they ask you to show your work, that would be how you would work it out. Your actual answer for the graph part of it would be to come back and go from negative 5 to positive 5 with a solid circle here and an open circle there with everything in the middle. Yeah, so that's, if there's any bad part about the AND statements, is you actually almost need two graphs. You need one graph to plot it out and see where you have your two colors that overlap, and then once you've got that, then you can go back and put your answer and see what you've got with it there. The OR statement, you never have to worry about that. You just pretty much just shade the thing and go. And, oh, one last thing, interval notation, just right underneath that. Well, we started at -5, and that was solid. We went up to +5, which was open. So there would be your answer in interval notation. Okay, and then one last problem. Let's go -5 less than 4x plus 3 less than 11. And for this one, they don't tell you if it's an and or an or. But here's basically where you can think about it. This is always, if they don't tell you what it is, that means it's an and statement. Because it's -5 is less than, and you can almost look at it this way. It's two things. It's -5 is less than 4x plus 3. And at the same time, it's 4x plus 3 is less than 11. So the 4x plus 3 goes with both the left and the right sides of it. And you can do this where you can separate the two things out, but here's the easier thing to do. Work from the inside out, and instead of just doing it to one part, that if you were pretending like this piece was gone, you would go back and add 3 on both sides. Sorry, you would subtract 3 on both sides. But because this thing had -5 in front of it, when you subtract 3, because it's got 3 pieces, now you've got to do it 3 times to all 3 parts. So if you have no words, it's an and statement. So you're still going to solve for x in the middle, but now instead of just doing it to 2 parts, because there's 3 parts to inequality, because you got a left and a middle and a right side, you still solve this thing like you normally would, but now you got to do it to all 3 parts. So that's a -8, that's less than 4x, which is less than 8. So then your next step would be to go back and divide by 4. And again, you're going to do it to all 3 parts. You've got the -2 less than x, which is less than 2. Now, here's the good thing about this one. And this one is the one you actually want if you're going to do an and statement. Because with this answer, they've already got everything set up for you that you don't have to do the 2 graphs at one time, because this is already telling you that when you graph this thing, everything you need is right there. You need to stay between -2 and +2. And at -2, we've got an open circle. And at +2, we've also got an open circle. So that shows up very well. Let me fix that. So open circle, color change. Open circle at 2, open circle at -2, and x is stuck in the middle. So it's just everything between those 2 numbers. So if on the problems when you're going through these, if they talk about solving that compound inequality, that's the easier problem when they don't give you the word and, because they've already told you that, all right, we're only going between these 2 numbers, so then just solve this thing and tell me what 2 numbers were between here. And interval notation is just as easy because it's the exact same numbers you've got here. It's just now we're going to go from -2 up to +2. And both of those we're going to use parentheses because they were both open circles. Okay, so that's your 2, if you want to call it 3 times, where you get the or, you've got the and, or you've got this third option where They don't actually put a word in here, but if you do that one, that's just an and statement. And again, that actually should be an easier and statement. And if you want to kind of start thinking about it, that when they don't put the word in here for and, that your answer, and this we'll tie this in here in a minute, it's always going to be sandwiched between two numbers, because you got the and in the middle of it there. So anytime it's an and statement, it should almost always be sandwiched between two numbers when you get finished with it. Okay, now let me show you a couple of parts where sometimes you may get a trick question. So still solving some inequalities here. Well, let's just show you what you could possibly get for a trick question. Okay, so 4v minus 3 less than 21, or 2v minus 6 greater than or equal to negative 2. Okay, so with the OR statement, first thing is we'll add 3 to both sides. We've got 4v less than 24. No negatives, so we don't have to flip any signs. Take 24 and divide it by 4, so v is less than 6. Okay, on the right side, just need to add 6 to both sides. We've got 2v greater than or equal to 4. Divide both sides by 2, so v is greater than or equal to 2. Okay, so they ask you to solve it. Now, in this case, I think for these, they don't even ask for, it says to write this solution. You're going to solve it, but the key thing is they tell you to write the answer in interval notation. So they don't even ask for the graph on this one, but again, you have to have the graph to kind of show your work to get to the point of where you're going on this thing. All right, so we need, what, 6 and 2? So there's our 2, there's our 6. We need everything greater than or equal to 2. So that's a solid circle at 2, headed that way. We need an open circle at 6, headed that way. And the good thing with this one is it's an OR statement. So what do we cover? Everything, right? Kind of back to the other part we had. So if you cover everything, your answer would be negative infinity to infinity, because you covered every single number on the chart there, so that would be the answer that you were looking for. And if they ask you to show that on a graph, well, that would be your graph. You would cover everything from negative infinity to infinity because you covered everything. Because I think if you graph this one, if it happens that you cover everything, that's one where you'd have to go back and just shade in the whole entire graph because you've covered everything. Now it's OR statement. So if it's OR, now if that was an AND, yeah, it would have just been this little part right in the middle. But by that, when it being an OR, you take anything at all that shows up, and we wind up covering the entire graph. So. Okay, and on the flip side of it, if you do one of these, if you do an AND statement, and you wind up getting a gap in the middle, then you'd have no solution. So they kind of go back to those same couple of things we were looking at back on the earlier part of what you could possibly have when you go through these. Okay, so everybody okay there? Anybody need one more? Or everybody all right? So we're good?